Yo, yo, wait. Yo, it's your boy, JOHHBRAHAM. We back, son. We back. Sons and daughters, we back. Organic chemistry, acid reaction. What is acid reaction? Substitute. Substitution reaction. You feel me, fam? You feel me? Basically, what you do is, I have this thing, right? What's it called? Oh, notebook. I forgot about it. And hey, we got an announcement. New mouse. I bought a new mouse, and I gotta say it's pretty fast, but I don't understand if it's too fast or I'm too slow. You feel me? Like when I use my computer, I set the mouse sensitivity to the max, and this one, I'm confused. Is this faster and my brain is having hard time to adjust to the sensitivity, or my brain is pretty fast but this mouse is pretty slow? Let's find out. I guess we found out in the future, huh? What's that? What was that? I think I should turn that setting off. That's not it. That's ain't it. Oh. I gotta say, it's really hot. Like, bro, I went outside. Yeah, the temperature is like, now it's showing 29, but that was not in 29, okay? It was like 35, 45, 55 degrees Celsius out there. I need to turn that setting off because my mouse is too sensitive, and I'm just going up, and I'm going up at the top left every time. Superbug, I remember that name. Team Fortress. Hey yo, what's up, man? Damn, I'm sorry, gang. The game did not run on my computer. What was it? Aromatic substitution. Yeah, this one. What is this though? Is it like a Superbug? You naked, yo? It's hot. It's hot as like literally. Literally, it's like really hot. I'm trying to forget that it's hot, but it sometimes just reminds me it's really hot. But yeah. But how you doing, Superbug? I'm guessing you're doing pretty good. I bought a new mouse and it's too sensitive. I need to change one setting. Reduce motion. Yeah, I turned it on though. Reduce transparency. It's on. Display contrast. Normal. Prefer horizontal text. Small pointer. Do I like it? I like it. Small pointer, I like it. but that's not the setting I was going for. It's display, but I don't know if it's gonna show up on the display part. True tone. No, that's not it. Desktop and dock. Position on the left side of the screen. Minimize windows into application icon. Automatically hide and show the dock. No. Animate opening animation show indicators. Desktop and stage manager. Where is the part where I have to go to the top? Mission control. No. Drag windows to the top screen to enter mission control. Displays have separate spaces. Group windows by application. When switching to an application, switch to space with no, none of that. Close windows when quitting an application. Nope, this is not what I wanted though. This thing. Yeah. What is that? What is that? Mouse going to the top left corner. Advanced. Pointer acceleration. Okay, now. Okay, I guess I can't change it right now. Fuck this. Fuck that. So, the last time I was looking into organic, why are we talking about dielectric constant? Developing charges on the transition state. While it is true that the intermediate is highly charged, rule A specifically refers to the transition state because that is the state which determines the reaction speed. Here's why the rule focuses on transition state rather than intermediate. The gatekeeper of reaction speed. If in any reaction the speed is governed by activation. I got 2 custom buttons. Wow, that's good. I can copy with that. No. I gotta set those. Okay. The intermediate sits in the valley after first energy hill. Even though the intermediate is highly charged, the reaction cannot happen unless the molecule first reaches the peak of the transition state. In SN2 reaction, the rate determining step is the breaking of the bond between the carbon and the leaving group, starting material, neutral, and less polar. Okay, I need to bring in the PDF. High dielectric constant solvents are excellent at stabilizing highly charged transition states. Dielectric constant are basically polarity. Yeah. Now it's starting to make sense. Okay. Mechanism and stereochemistry of SN1. Homo-LUMO interaction. Homo is... Oh, fuck. Homo is when both... Highest empty orbital? Fuck, I forgot Homo-LUMO. Isn't solvent effect, the starting material can either be ionic or uncharged, as well as the products. Effects of strong ionizing solvent on reaction rate compared to reaction in an apolar solvent. Similar, significantly faster, significantly slower. Significantly slower, okay. Did I set the timer? No. 1 hour. 45 minutes. 30 minutes. 15 minutes. 20 minutes. Whew. Gotta clean this one. The old mouse, I have to clean it. And it's still working, okay. So what was the last thing I wrote? We got polar protic solvent like water with high dielectric constant. It helps in SN1 stabilize the carbocation. SN2, it causes a cage effect on the nucleophile, so it hinders SN2. SN2 is the one where there's no transition state. SN2 is the one where there is no transition state, right? Or intermediate. No, intermediate, okay. Yeah, SN2 is the one that has no intermediate. It has a transition state, but transition state is highly unstable, if I understand. Yeah. Now for polar aprotic solvent, it has no specific effects. Dissolve cations, helps SN2 reaction, results in a more reactive nucleophile. Okay. So it dissolves the cations that are formed after the reaction with the the reaction with the reagent type shit. I feel like that's it. No, it's not like that. Okay. Inverted configuration. Oh, those are older ones. So polar aprotic solvents are the ones that has polar molecules that cannot form hydrogen bonds. So they don't. So if I arrange the dielectric constant of the solvents in a descending order, it's gonna be polar protic solvent. Then, oh, come on, man, stop doing this, man. Polar aprotic solvent. Then non-polar aprotic solvent. Boom, boom. Oh. Ow. Come on. Nope. Did not break. Fuck. Maybe if I tried it one more time, it's gonna be the end. Based on the table, you suggested descending order is generally correct, especially when you look at the best examples of each category used to promote a specific rate. Okay, okay. So I could also arrange them, but holds true for strongest examples. There are overlap in the middle. For instance, ethanol, a protic solvent, has a dielectric constant of 25, which is actually lower than DMSO or DMF. Okay. But in general, I could say this could be right. So if the reactants are less charged than transition state, a protic polar solvent speeds up the reaction, SN1. If reactants are more charged than the transition state, a less polar solvent speeds up the reaction. Okay, transition state. The peak state at the molecule is at when it's forming new bonds. Applies to both SN1 and SN2. Highest energy point of the reaction. Okay, that's the transition state. Most often SN2 slowed down by protic solvents due to strong solvitation of nucleophile by the solvent. Reaction speeds up significantly by use of polar aprotic solvents, stabilize the transition state, and dissolve ionic reagents. But how? So here we're saying, wait, here are we saying that the polar aprotic solvent is gonna stabilize the transition state for SN2 reaction? Wait, I thought the solvent can't do, or we can't do anything in general against the transition state, like we can control it. Yes, according to the lecture notes, polar aprotic solvents do instead symbolize the transition state in SN2 reaction. Well, it might seem like transition state is an untouchable black box because of its short lifetime. Chemists can absolutely control it by manipulating its environment. Absolutely! Like, Okay. Okay, I'll see it. Mm-hmm. Especially the solvent. Here's how the solvent controls the. Yeah, I thought it was a black box. Stabilizing the smear charge in SN2 transition state, the negative charge is delocalized between the incoming nucleophile and the departing leaving group. Polar aprotic solvents. These solvents are polar enough to interact with the delocalized charge through ion-dipole interaction. By surrounding the transition state and providing them electronic stabilization, they lower its energy. Apolar solvents, in contrast, yo, somebody used to chat. Could you help me visualize this with an example? Somebody used to chat. Who's that? Who's that? It's Crotchetef. Yo, what's up, What's up, gang? How you doing? Yuhi. How you doing, Crotchetef? Is it your first time checking out the stream? Cause I feel like I never seen that name before. Good? Well, good to hear that. Yep, to the question on is it your first time checking out the stream? Okay. Well, welcome, Crow Chef. Not gonna lie, it's a lot of C's. 1, 2, 3. 3 C's. I'm gonna call you Crotch. Well, basically what I do is I just thought, why not stream what I'm studying? It's Crochet Chef. Okay, Crochet Chef. Crotch sounds better though. I'm just saying. Crotch sounds better. But hey, yeah, if you're wondering what I'm doing, basically, I was like, back in the day, I was like, oh, I have to study no matter what. Why not stream? Here we are after 1 year. And it did help me a lot, okay? I'm not gonna say it did not. So let's take OH minus plus CH3Br. In this reaction, the transition state is higher energy point where OH minus is halfway attached and Br minus is halfway detached. Yeah. The charge, the single negative charge that is concentrated on the oxygen atom in the OH minus is now smeared. Back in the day, are you from the 18th? Yo. Back in the day could mean yesterday, okay? It was like 1 year ago. It was like 1 year ago, gang. 1 year ago, I was in the very bad stage. I was failing exams left and right. I was drinking every day. I was smoking every day. I was doing drugs. Nah, I'm just kidding. But yeah, it was not in a very good stage. And I was like, okay, I gotta make some difference. I gotta make some changes. Stream. Polarization. This state is highly polarized, meaning it has a specific arrangement of partial charges as bonds stretch and form. Is it really loud? I don't think so. A state is highly polarized, meaning it has specific arrangement of partial charges as the bonds stretch and form. Scenario A, in polar aprotic solvent. Polar aprotic. Okay. The transition state surrounded by DMSO molecules is a polar molecule with strong dipole. Okay. the ion interaction because the transition state is polarized. The DMSO molecules can orient themselves so their positive point towards the areas of the developing negative charge on the HLBr parts. The scaffolding effect. These solvent molecules act like an electric scaffolding or cushion, providing a comfortable environment for the delocalized charge. This lowers the energy of the transition state peak, making energy climb easier and reaction 10^3 to 10^6 times faster. But I'm confused about if this could provide a polarized, like a comfortable state environment. The polar protic solvent should also be able to, or am I missing something? 15 minutes? I'm still on the same topic that I was doing last time. Huh. Huh. Aprotic solvents, hexane. Now imagine the same transition state in hexane. Hexane molecules have almost no dipole, lack of support. When the polarized transition state tries to form, the hexane molecules just sit there. They cannot orient themselves to provide any electronic stabilization because they don't have charged ends to interact with the transition state. Hindered formation. Without this environment support, the energy peak remains extremely high. The transition state is so unstable in this environment that it is hindered from forming at all. Furthermore, the ionic OH minus starting material likely wouldn't even dissolve in hexane to begin with. It would not. Summary for visualization. Polar aprotic solvent. Think of it as a supportive crowd that uses its own dipoles to hold up and stabilize the smeared charge of transition state, making the reaction much easier. Apolar solvent. Think of it as an empty room. It provides no electronic help, leaving the polarized transition state to bear its bare. Beer? Really? Bare. Its own energy burden, which usually may. So, okay, I kind of got it. But did I write down the scaffolding effect? No. Scaffolding. Stabilize the. Oh shit. Intermediate state, yep. Glass is not good. Glasses are not good. So, summary for visualization. Think of it as a supported crowd. Okay, so I kind of got it, but how is the polar protic solvent working here? No, 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 that's not what I meant. No. No, I just want to know difference where the protic polar protic and it's gonna stabilize the transition state for SN2. 20 minutes, god damn it, SN2. Let me know if what? Let me know if the bonds in these two solvents being different is the result for the drastic change in favoring like the polar protic has covalent. I don't think it has called covalent. I don't think it's covalent is involved here. And the polar aprotic has ionic. So we got some examples for protic, dielectric constant, down, down, down. Should I memorize these? Most likely, yeah. Most likely I should have memorized. To clarify the difference in how these solvents affect the transition state, we should address the nature of the solvents themselves and look at how they interact. Misconceptions: covalent versus an ionic. Yeah, I was wrong. The drastic change in reaction speed is not because one is covalent and the other one is ionic. In fact, both polar protic and polar aprotic solvents are covalent. They are covalent molecules, but how, like the individual molecules have covalent bonds, but how do they behave as a molecule, like as a solvent? How individual molecules interact. I was going for that. Are molecules held together by covalent bonds, just like water and methanol? Yeah, intermolecular interaction. That's the word I was going for. That was where I was also going for. Okay, don't act like you know shit. I should shut the fuck up. Specifically, how they interact with the reagents you put into them. Both solvent types provide some level of stabilization to the transition state, but they do so with very different intensity compared to how they stabilize the starting materials. Polar protic solvents. These solvents stabilize anions like your nucleophile very strongly through hydrogen bonds. In SN2 reaction, the starting nucleophile has concentrated localized negative charge. The transition state, however, has a smeared, that's the word, right? Smeared, or delocalized negative charge shared between the nucleophile and the leaving group. The starting nucleophile has a concentrated localized negative charge. The transition state. Wait. Polar protic, these solvents stabilize anions like nucleophile very strongly through the hydrogen bonds. The new starting nucleophile has concentrated localized negative charge. The transition state, however, has a smeared or delocalized negative charge shared between the nucleophile and the leaving group. Because the protic solvent is good at forming H bonds, they stabilize the starting nucleophile. So it's H bond, not some sort of polar. Well, they stabilize cations using. They are poor at solvating anions. So what type of bond is this? What form of intermolecular reaction is this? Interaction is this? Wait, what? Ion dipole. Okay, ion dipole. Ion dipole. Okay. Gotta write that down. Bad. Ow. Should I change the camera? Yeah, I should. You guys ready for the best transition out there? Oh, it's gonna be crazy. That's just Josh Abraham flipped. Yeah, basically. There we go. Not gonna lie, the wide angle length looks crazy. You can see the whole hand, but you can't see too much else. Yo. Yep. Better. Forms H bond with polar aprotic, forms ion dipole Yo, you have completed the same. Well, I still haven't completed yet. Ask if you have any doubts. Well, I just got one part clear with how polar protic solvents interact with with the reagent. So basically, polar protic uses hydrogen bond. That is why they cannot fuck. That is why they cannot hold the transition state for SN2 reaction, which is the ultimate reason why polar protic solvents cannot support SN2 reaction, because it forms hydrogen bonds with the nucleophile, kind of pushing the reaction to the left, while polar aprotic solvents, which increases the speed of the reaction, increases the speed of SN2 reaction, actually uses ion dipole force, intermolecular interaction, which holds the transition state, or it kind of gives it a comfort position. It kind of provides stable charge for the transition state to be more stable, which results in equilibrium of SN2 reaction shifting to right. Yeah, I kind of missed. I was not able to pinpoint out. Polar protic solvents come in picture for SN2 reactions because the rate of SN2 depends on the type of solvent. Yeah, I was thinking, why is polar protic increasing the speed of SN2 reaction? The reason is the weak bond. The weak ion dipole bond kind of holds the transition state for SN2 reaction. It kind of provides a stable charge state. It kind of provides charge for the transition state to be stable, which shift the equilibrium to the right. Yeah, that's what polar protic solvents do. They form H bonds, which reacts with the nucleophile. Forms ion dipole interaction with the transition state which stabilize, promoting SN2 reaction. Oh, yep. Man. Promoting SN2, what else? So that's what polar aprotic solvents do. But both of the solvents are covalent. Okay. Can I say this weak ion dipole moment? Can I say the weak ion dipole intermolecular interaction between the what? Transition state in SN2 and same as ionic bond, or is ionic bond exclusive to Shalom says, why are you naked? Bro, right now it's showing 28. That's not bad. But it's really hot. You don't understand, bro. You do not understand. It's hot. Look at this. Look at this. Oh, did I reveal my location? Nah. But you see that? That is hot. That is hot. So what was I asking? Or is ionic bond exclusive? Exclusive to what? Intramolecular. Did anyone tell me? No, nobody. Not even a single human being. But hey, I heard Sweden is a really beautiful place. I wish I could visit. I need to visit a lot of places. Not gonna lie. And when you said Swedish, the first place that I want to visit nearby is the mountain Alps. Oh, that's good. No, you cannot say weak ion dipole intermolecular interaction same as ionic bond, while both are electrostatic in nature. Okay. They differ significantly in their components and strength. Furthermore, ionic bonds are not exclusive to intramolecular interaction. Okay, so I'm just wrong in multiple ways. According to according to Notebook LLM, I'm just wrong. Like it did not even acknowledge, yo, you tried. No. No, the doubt is pretty simple. I just asked, is ionic bond similar to ion dipole interaction? So it is similar in its electrostatic nature, but you cannot say ionic bond is same as ion dipole interaction. Ion dipole interaction occurs between a charged species and the partial charges. Ionic bonds not exclusive to intramolecular, but in fact most classical examples of ionic bonding are intermolecular, forming large lattice structures. So, okay. Intramolecular ionic interaction in organic chemistry, particularly in large bioorganic molecules. The source note that electrostatic attraction are one of the key factors to stabilize the tertiary structures. Oh, so it's different. Ionic bond is still an intramolecular interaction. No, it's an intermolecular interaction. Oh, okay. I thought it was intramolecular. Okay. Damn. Did not know that. Gotta write it down. Ionic bond not equal to intramolecular ionic interaction, or let's say ion dipole interaction. And let's say, but they are based on electrostatic what? Or electrostatic what? I don't know. Electrostatic interaction? Okay, I'm not gonna go deeper into this, but let me just confirm what you mean by electrostatic, because my brain is not good enough to remember. Could you explain what is this electrostatic nature they have in common? Give me some questions, damn it. Well, could you explain what is this electrostatic nature that ion dipole interaction and ionic bond have in common? Because I forgot what this electrostatic nature is. Damn. DeepSeek is taking too much time. Like, too much time. The electrostatic nature of ion-dipole interaction and ionic bonds have in common is that fundamental principle of charge. I showed yo, chill, okay? There's nothing wrong with my nipples. It's a completely normal nipples. Ion-dipole interaction and ionic bonds have in common is that fundamental principle of charge attraction where opposite electrical charges exert a force on one another to bring components together. According to the sources, this electrostatic commonality, it's a fundamental principle of charge attraction where opposite electrical charges exert a force on one another to bring components together. Okay, full opposite charges, ion dipole interaction, attraction between a full charge and a partial charge. Okay. A full cation, a full anion. The ion with I understand. That makes sense. This partial charge is the transition state. I get it. So, ionic bond, attraction between full opposite charges. Full anion. Attraction between a full charge and a partial charge. Between full charge, partial charge. So ion and partial charge. Control your emotions. In ionic bonds, this attraction between full opposite charges roles in bringing reagents together. The source state that this charge attraction is what brings reagents together in a solution, allowing them to collide and potentially react. Whether a charge is permanent, full ion, or partial dipole, the electrostatic pull is magnetic force that initiates the interaction between the solvent and the transition state or nucleophile. Whether the charge is a permanent, full ion, or partial dipole, the electrostatic pull is magnetic force that initiates the interaction between solvent and transition state or nucleophile. Stabilization of the structure. This shared electrostatic nature is a key factor in stabilizing chemical species. No, that's not what I was going for. Okay. Energy of interaction. Both interactions are energetically. Yo, Vibov, I bought a new mouse. Let's go. Got a new mouse. My old one was like a teeny puck. Oh. You might be asking why the new mouse? So basically, I have this, right? I can use this mouse to use this. Now I can watch porn. No, that was a joke. But yeah, I can use ChatGPT like this. I can open calculator, books, files, notes. That's cool. But this new mouse is pretty high the sensitivity is pretty high. I need to control that. I need to adjust to the new high sensitivity. Can you help me with the part, with this part. Mainly, can you let me know the ion is part of the polar aprotic solvent, and the partial charge charge is from the transition state for the SN2 reaction, or is it the other way around? 45 minutes? Goddamn, 45 minutes and I'm still here. I'm still here. Like bro, bro, you It's actually the other way around. What you suggested in the context, SN2 reaction being stabilized by polar aprotic solvent, the transition state acts as an ion. Okay, the transition state is the full charge entity, and the polar aprotic solvent provides the dipole partial charge. Okay, and that's what makes it stable. Electronic scaffolding. Okay, I need to remember that term. Beep, beep, beep. Yeah. No. Solvent. So this bond provides the electronic scaffolding. So what? Okay, I kind of understood that, and I just need. Fuck the sensitivity. I hate it. I hate it and I love it. I hate it and I love it. Okay, just give me a small explanation on what exactly this does. I know it's kind of situation where the solvent provides electronically stable point position. Effects on SN reaction. Comparing two nucleophiles of the same size, the stronger the basis, the better is the nucleophile. Electronic scaffolding refers to the way polar solvent molecules surround charged species, like transition state or orientation of charges. Polar solvents orient themselves to their partial charges, point towards the opposite charges of the reactant. Okay. Energy cushioning. This arrangement acts as an electronic cushion that lowers the energy peak of the transition state. Acts as an electronic cushion. Electronic cushion that lowers the energy peak of transition state. Fuck. Okay, good. That looks good. Why did I do that? I just felt like I want to do it. Yep, that looks good. Oh, energy cushioning. Lowering activation energy by stabilizing the transition state more effectively than starting materials. The solvent reduces the height of the energy that hill the reaction must climb. Okay, that yeah, I got that. I got that. Okay, what's the next part now? Reactivity of organic compounds. Should I write this down? Should I memorize this? Some boom, 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 boom. Yo. Based on the lecture notes and the nature of solvent effect discussion, you should focus on memorizing the categories and general trends rather than specific numerical values of the dielectric constant. Here is what is most important to take away from table 10.7. Uh-huh. You must be able to identify which solvents are protic, which are aprotic. This determines the reaction mechanism. Protic examples. General trend, instead of memorizing the DMSO, is exactly 47. Remember the relative scale. Understanding the relationship. The most testable information in that table is the rule stands. Higher the dielectric constant, the more ionizing is the solvent. This concept is what allows you to apply rule A and B that we discussed earlier. I don't remember what is rule A and B, but hey, I'm gonna write this down. Ah, I hate it. Ugh. This much space, how do I control it? I could write the topic heading. Yo, look at this. What the what the fuck? What is this? Oh man, oh, oh, look at it. What is it? What's that? What's that? Ah, oh, what the I'm not gonna look further. Oh, that's gonna fucking give me a heart attack. Dielectric constant of common solvents. Dielectric constant of some solvents. Solvent. Structure. Do we need the structure? Yeah, let's just write it. Fuck it. Abbreviation. I'm just gonna write the abbreviation. Oh, not everyone has structure or abbreviation. Dielectric constant. Boiling point. Water. Drinking water. One of the most abundant. H2O. Dielectric constant 79. Boiling point 100. Formic acid, is that the one we get from, ants? I heard some ants produce formic acid. 59. Oh, that's also 100. Interesting, okay. Methanol. MEOH, right? 33. That's 64.7. Ethanol. ETOH. Oh fuck. Did I just write the whole thing? ETOH, yep. 25, 78.3. Tertiary butyl alcohol. CH3COH. 11. 82.3. Acetic acid. ACOH. HOAC, okay. Okay. Never thought like that. 6. 117.6. 49. And these are all polar. Polar. I'm guessing it's all okay. In the table, it's 1 hour. Goddamn. In the table, it's written that it's only protic and aprotic. I'm guessing all are polar. I'll be fine once I get it. I'll be good. I'm in the pursuit of happiness, and I know we go again. I'll be fine once I get it. I'll be good. It's a good song though. Pursuit of Happiness. I just realized how empty my stream sounds. We should have a background music. Like a set of clean beats just playing on replay. Just if you understand, fam. Like some very light beats. I feel like that could make a really significant difference. Why? I don't know. I just felt like I could make a difference. I just Yo, somebody said my name. Yo, Devoto did. Yo, what's up? Appreciate you for checking out the stream. based on your guess is partially correct. There's an important distinction to make regarding the aprotic category. While all the protic solvents listed are indeed polar, the aprotic category includes both polar and apolar. Here's a breakdown of how the table is organized. Protics, aprotic, mixed polarity. Mixed polarity. Dielectric constant. Higher the dielectric constant, more polar is the solvent. Okay. Okay. Five minutes. Timer till 2:30. Timer till 3. Oh fuck. Timer till 3:30. Good enough. Fuck. Yo, why is it so huge? How many more minutes? Not too much. Puh, puh. Not too much. Like 120 seconds, literally. That's pixelated, bro. Okay. Literally pixelated. Oh, I just realized I'm sitting like a fucking caveman. I gotta sit straight. Like. Oh no, what have you done? No, that's not it. That's not it. Okay. Let's do this again, okay? Alright, it's done. Let's see. Yeah. Better than before. Okay, gang, I'm gonna open GIMP for just a minute. Because I gotta make a new thumbnail. Just a minute. Let's open it here. Or the whole thing. Yo, JEE Dropper. Well, what's up with the name though? What are you grinding for? Basically, I got some exams to pass and I need to pass those exams. It's organic, inorganic, math. These are the exams that I need to focus on. And yeah. And I'm grinding for I don't know, to complete my degree, to get into a field, get into my field. That's what I'm grinding for. To get into the bio labs. You feel me, fam? Good luck, buddy. Yo, what happened with your username though? Did you drop JEE? Like, no offense. Like, I understand if you don't want to do JEE, but you know, I was just asking. Like, I need to get my face the size of that, but before that, oh, it's too small. Bam, 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 bam. Hell yeah. I took an extra year for engineering entrance exam called JEE. Yo, I know JEE, bro. I was almost the same route. I took a NEET exam. But so you took an extra year for after 12. So are you doing are you preparing for JEE? Cuz your title is said JEE dropper. What's up with that though? Scale. Oh, that's too small. So you dropped out of JEE. Okay. I mean, hey bro, you should have other plans, right? You should have other plans if I understand. This is the hardest part. How do I erase it? Extra year is called a drop year. Yo, drop. I mean, there's no drop year. You just meant a dropper. The title, your username is said the dropper. So I thought you just did JEE once and you just dropped the exam. I mean, hey, no offense to people who do that, because I'm one of those. I didn't retake NEET. Fuck retaking NEET though. Okay. Ah man. You know what? Let's go to the rubber. I want the neck to be right there at like in between the symbol. You'll see what I mean. I'ma head out, bro. Good luck with your thing. Yo, respect for checking out the stream. Good luck on the exams. It's uh, it's a good world out there. Oh fuck! I fucking hate this. I hate that I cannot control it. Let's go a little bit smaller. Yeah. Make it bigger in a way that it's a waist face. Yeah. And now we rub. Now we erase. That's even harder. Oh shit. Should I try that? I want to try though. I was writing this. Polar protic. Dimethyl sulfoxide. Acetonitrile. Dimethyl formamide. Formamide. Hexamethyl phosphoric acid triamide. Oh. Hexamethyl phosphoric acid triamide. Why is the triamide at the end? Acetone. Dichloromethane. Tetrahydrofuran. Tetrahydrofuran. Ethyl acetate. Diethyl ether. Benzene. I should have written the name. I should have done that. Fuck. Dichloromethane CS3 twice. Somebody said HLO, bro. Hello. Basit Majid. Hello, gang. Hello. What was it? Dichloromethane DMSO. 47. I'm stupid, huh? I am a little bit stupid, I guess. CH3 twice. SO. What's the dielectric constant? 47. And boiling point is 189. CH3CN. Bro, I need a stylus for a Samsung 11.5. 11.5G. 11. No, there's no point. 11.5G. I'm guessing it's 11-inch tablet. 5G? Okay. Please tell me which one is the best. If I understand, all those styluses work almost similar, right? Yeah. Or does Samsung have their own Samsung stylus? Which device is this? Samsung Tab 11? Okay. What is their stylus? Do they have their own stylus? Okay, they do sell their own pen, and there are a lot of alternatives. And yeah, I mean, I don't know. I don't think you should always get the official pen every time. You could just get the cheaper version. That should work. That's what I feel like. I don't know. I never tested many devices. But what would be your use case though? Is it like studies, writing notes type shit? Can you show me your stylus, please? This is a normal stylus, if I understand, but it's the worst stylus out there. Look at this. Can you see it? It's just the size of a normal pen. If you go for a normal pen, as the thickness. Can you see the thickness? It's almost the same, huh? Yeah. But I feel like the real pen is much lighter. This is more heavier. But Yes, for note making. Okay. I don't think you should go for the official Samsung stylus. You could get cheaper ones and it should work just fine. That's what I think, but hey, I never use I don't know too much on that. Acetonitrile 38. 38 what? Dielectric constant. Yo, you see that? It's not working. Stupid. You stupid. Yeah. Sometimes this is just not work. This just does not work. 38, 81.6. Dimethyl for CS3 twice and CHO. And CHO. 37. Are you preparing for NEET? No. I did try NEET once and I failed miserably. Like, miserably failed. I don't know, failed? I did pass the exam, but I did not get enough score to, get into the big universities. But no, right now I'm preparing for my university exam, not like a very big exam. 153. CH3 twice and thrice PO. CH3 twice. CH3 twice and thrice. Yeah. Yo, where are you from? I'm from the land of the spice. I'm from the same country where NEET is held. Let's go. South, Kerala. 30. 30. And 233 is the boiling point. That's a really high boiling point. Even though the dielectric constant is not that high. You're from Kashmir. Yo, that's like the other end. Yo. Let's go. How you doing? It's pretty cold out there, right? Kashmir is really cold. Or would you say it's different? It's not that cold right now. CS3 twice CO. Twice CO. 21 is the dielectric constant. 56.3. Okay, that makes sense. But 233, that's too high. CS3CO. CS2. CS3. CS3, CS2. Oh, CS2. CS3. 4.3. 34.6. Benzene. If you don't know benzene, it's a joke. Kill yourself. 2.3. 80.1. Hexane. CS3. CS2 4 times CS3. $68.7. Okay. So I can't say these are all polar. Polar what? Polar. These are aprotic, but not. So. Okay. I just wrote this down. And I'm confused on the aprotic, like above a specific dielectric constant is gonna be considered as what? Considered as what? Polar. And below that is non-polar. I don't. Yo, bro, I'm in class 11th right now. I want to be an IPS officer. Let's go. We need more better people. Let's go. So for that I have to clear UPSC. Oh, UPSC. Can you tell me something that would help me to clear this exam, like some tricks or tips or tricks? I don't know too much about UPSC exam, but you could search up older question papers and stuff and plan for the exam. Like planning is the best thing I ever seen. Like I know people who plan for 1 year. They know how every week is gonna go. And if you could plan like that, very good. I'm still not there yet, but I feel like planning is a really cool thing that we can do. That this thing can help us. But yeah, that's all I could say right now, because I'm 22 and I failed a lot of subjects. Like I'm not a very good at studying person, but I'm trying my best though. Polar high roughly 15 to 20, greater than 15 to 20. Oh, okay. Less than 5, greater than 15 to 20. Okay, so here polar aprotic solvent. Bum, 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 bum. Fuck. Apolar. Sorry for this, but I'm a little bit confused here. What are you preparing for? Okay, simple. Tell me, What is your ambition? Oh, damn. Right now, I'm preparing for an exam on organic chemistry, which I failed a lot of times. Yeah, I'm preparing for organic chemistry exam. Ambition. I wanna do research on. Right now, I could only say the broad term biochemistry, but the more I learn, I could be more specific. But right now, let's just say I want to do research on biochemistry. Again, that's such a broad thing to say, yeah, because I still need to know more. I still need to learn, understand more to say where specifically do I want to research. But let's just say right now, biochemistry. But okay, so dielectric constant. Did I write the symbol? No. Okay, in the polar solvent, there are cases with the dielectric constant being like 6 below 15, and I'm guessing they are still polar solvents. Effects of Hessian reaction. The strength of the nucleophile is dependent on the basicity, polarizability, solventization, and steric effects. Your guess is correct. Radical and aromatic reactions. Dude, my sister is in nuclear sister is nuclear researcher or nuclear. I don't know what nuclear is. I'm gonna search it up, but in New York. Oh shit, damn. I guess New York does have universities that does nuclear research. Okay, I'm guessing. Yeah, it should be nuclear. Yep. It's a really interesting thing, right? It's nuclear. Really, really tiny particles that contain a lot of energy. Comparing nucleophiles with the same attacking atom, the stronger base is the stronger nucleophile. Uh-huh. But is this, and I know you're gonna smash this exam. Let's go. Appreciate that, bro. And like I said, I should also increase my timetable. Like I need to plan more. Right now, for the past couple of days, I did not plan that much. I need to plan more. Oh. And I gotta say, I tested and I'm not gonna say I tested on myself, but I proved to me that if I use timetable, it actually makes a big difference. But but I think the hard part would be staying consistent. Dude, I'm subscribing you. Respect, let's go. Correct it up. It's a correct it up. Basit Majid, are you using the vertical stream, the vertical one, or the horizontal one, the big one? Because there's two streams going on. And I could make. Dark space at the top is not that important, huh? No, it is not. Ads. Fucking ads. Fucking ads. Okay. Functional polarity was a ability. It's good enough. Bro, are you learning some skills like coding, Java? I looked into Python a little bit, but that would be it. Anytime I need to write some code, I need to write the small. Anytime I need to run a small program, I just use AI. I know it's not good. I know it's not as efficient as we code, but I don't know too much about coding, so I use AI to code. So I cannot say I code. It's like those vibe coding type shit. Yeah. Not proud of that, but hey, I gotta get my things done. You know something about white hackers? No, I don't know anything about white hackers. What is white hackers? Damn. What do they do? Like they're like the people who go into government files and just leak it for the sake of it. Comparing two nucleophiles of the same size of stronger base is the better nucleophile. Reaction rate of SN1 reactions independent of the nucleophilicity of the reagent. I don't get. Yeah, bro, ethical, or you can see legal hackers. Oh, okay, yeah. I heard this. I heard those. So I don't know too much, but I heard this term where there are hackers who work for the government type shit. Effects of SN reaction. Okay, I'm moving. I don't know. I'm confused. Mainly, they showed us that OH minus is better nucleophile compared to H2O, and I was wondering, OH minus is an anion, while H2O is a molecule. How is that gonna work? Like, how are these considered as nucleo? I know OH minus is one, but H2O is not a nucleophile. Or am I wrong? I guess I'm wrong. Based on the lecture notes, you're not wrong. OH minus is a powerful nucleophile, but both technically considered nucleophiles. What defines a nucleophile? Defined as an electron-rich compound that donates an electron pair. Crucially, the source states that it would mean a lot to me if you could give me a small shout out in one of your YouTube videos by saying something like, Muhammad Basit, you're a talented and dedicated ethical hacker. Keep learning. Yo, I thought you were into this thing. What's it called? I I thought you were going for a UPSC exam. When did you move to ethical hacker now? But hey, if you're into hacking or if you're into computers, yeah, I mean, I guess keep learning, bro. It's like part-time. So you're sure it's ethical hacking, right? Because there are scammers too. There's a lot of scammers. even though it has no net charge, it's still electron rich because the oxygen atom has two lone pairs of electrons that it can donate to form a new bond. Okay. Bi is OH minus petronucleophile. Comparing nucleophile with the same attacking atom, the stronger base is the nucleophile. Okay. Why OH minus is a better nucleophile? I understand that it has more negative charge. Mechanism requirements. Your notes mention that SN2 reaction requires so strong charged nucleophiles like OH minus to proceed efficiently. On the other hand, SN1 reactions can work with less reactive uncharged nucleophiles like H2O because the reaction does not depend on the nucleophile's strength. Beep, 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 beep. Your notes mention strong. SN1 reaction can work with less reactive. Neutral molecule, strong base, very weak base. Oxygen attacking atoms. So for SN, so both are okay. So one is, so if, again, if you're okay, if you are saying water is best used for SN1 as a solvent, then how is it considered a nucleophile? In comparison with OH minus, which is a nucleophile used for SN2, yeah. Strong nucleophile attacks low DG. What is DG? I don't know. No, bro, you can trust me. I'm not harming anyone here. God swear. Please, bro, your shout out will help me a lot to grow followers on these. Yo, I gotta say, bro, I don't think my shout out is gonna work out. Like, hey, bro, good luck with the Basit Majid. Good luck with your studies. But I'm gonna say this right away. I don't think my shout out is gonna increase your Instagram followers. But hey, I yeah, I just want to tell the truth though. But if you're into this, good on you, bro. Mohammed Bashid, good on you. Damn. Comparing nucleophiles of different size, the polarizability of atoms become relevant. Tendency of a charge distribution to be distorted. Well, based on the lecture materials, the confusion often arises because water plays two different roles at the same time. Oh, nucleophile is defined as an electron-rich compound that can donate an electron pair. It does not matter if okay. Hydroxide nucleophile is in a full negative charge. A neutral nucleophile that uses the lone pairs of its oxygen to donate electrons. Strength difference. According to the basicity rule in your notes, when comparing nucleophiles with the same attacking atom, the stronger base is the stronger nucleophile. Okay. But again, I don't know, it feels pretty weird though. It does feel pretty weird though. Can I see this Instagram account you're talking about? Because why would you need me to say something? Like, I don't see the relation though. Yeah. Because I never had someone just come up to the stream like this. Basit Naim. Is this you though? You're also feeling weird, seriously, not gonna lie. Me too. But yeah, like, I thought you were into UPSC, but now this is a part-time thing. Mm-hmm. What's your Instagram handle, gang? You told me you will get more followers on Instagram if I shout out? But hey, good luck on your studies, gang. I really want to say that. Good luck on your studies journey. Tendency of a charge distribution to be distorted from its normal shape by external fields or charges. Can be compared with hard and soft acid-base theory, Pearson's concept. Again, I'm confused. Like, so basically, stronger nucleophile are just anions. So example, the stronger nucleophile are basically anions. Yeah, all of them are anions. What's with that though? Conjugate base rule when comparing, yeah, it's basically the conjugate base. Mechanism requirements. Comparing nucleophiles with the same attacking atom. The stronger base is the nucleophile. The strength of the nucleophile is dependent on its basicity, polarizability, solvatization, and steric effects. SN2 reaction, okay. Reaction rate of SN1 reaction independent of nucleophilicity of a reagent. Fuck. This camera is getting in me way. You know what I can do? I could make the camera go up. There we go. That's a position that it could be much better. And now I zoom in, right? I zoom in. Whoa, what was that? Yo, that's so cool. Yo, I did not expect that to work. Yo, fuck. That's me. Whoa, I did not expect that. Okay. That's the full wide angle. That's basically the whole desk. Okay, that's cool. But let's keep it simple. Low power, okay. Yeah, that's better. That's cool. Yo, you just placed a dot. Mr. Blow. I'm starting to get hungry. Fuck, I need to eat something. I do have some food. What if I eat it right now? I could eat it, but boom, 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 boom. Yeah, I'm gonna mute for a bit. I'm gonna eat something. I'm gonna mute for 30 minutes. Yeah. Because I need to eat something. Be back in 30 minutes. Let's go. I'm gonna mute for a bit. Fuck, I forgot how to do all that. Was it 30 minutes or it was more than 30 minutes? Please don't be more than 30 minutes. Gotta check it. Listen, bro. I'm listening, gang. I think you send this message. Oh, 15 minutes. It's less than 30 minutes. Okay, that's good. Good, good. Very good. Very good. You know what? I still got 15 more minutes, right? I'm gonna do something. Gemini. Fuck, I hate Gemini's new app. Oh, whoa. This is the program that I use to separate myself from an image I take of myself for making thumbnails. Things like thumbnails. So I want you to make a change where the final picture has a black and white cartoonish look, like a manga type of cartoonish look, but don't change any physical appearance. Just make the image a black and white so basically, after asking me about the transparent one, ask me if I want the cartoon black and white one or the normal color slash original. I'll add more edits that I want on this last part. Let's see how good it makes. $12 minutes.
12 minutes.
Okay. Let's see if it works. Oh no. Let's print this again. Let's see how many changes it does. One. Transparent. 2. Is it as good as I want it to be? Nope, that's not it. type of the script. Oh no, it destroyed it. Fuck. The face is fully destroyed. Okay. Okay. I just got the result, and my face is fully. No, it didn't fully complete. Okay. Oh no, that's black and white. Replace your current if filter mode equals 2. Okay. Photo filter. Okay, let's do this. Oh god damn it. We're getting there, but my face is getting completely destroyed. Oh, it looks good though. Okay. Okay, much better. Before. Yo. Besit. Bro, what is this? What is happening right now? Can you see what's going on? No. Oh, the screen is just... That's so weird. The screen just keeps on crashing. Why is it? Why is it crashing? You'll be back? Yeah, I mean, I just got back early though. എന്തൊക്കെയുണ്ട് മച്ചു ഫുഡ് കഴിച്ചോ? I'll be having my food in a while. I did have a little bit, but that's it. Appreciate Shashi Kumar for checking out the stream, gang. Appreciate that. The face is starting to be more visible, but it's still filling in a lot of places of my face with just extra dark color, which makes my face look disfigured when zoomed out. Can you move the curtains in the back so you can see the outside? So I kept it closed. Can I join you, bro? Well, you're in the stream. You're on the stream, gang. The curtain. So basically, I kept it closed because it's hot. The sunlight comes in, it makes the room hotter. That's why I kept it closed. Basically, it's just a bunch of trees. Nothing too much. Nothing too special. Just one time? Yeah. I could do that. One time I could do that. Ah, fuck. Just a minute. I'm in the middle of something. Where is it? Copy. One. Okay. I'll open it up. I don't know if the camera's gonna. Can you see something? No. It's so bright. Okay. Yeah. Basically, that's it. I'll do one more thing. Transform, rotate, flip vertical. Yeah, that's how it looks. Oh, yep. What's the time right there? Right. Stop. The time is 5 o'clock. 5 p.m. Yeah, it is pretty nice, but the view is nice, but it's hot. It's so hot. Where am I? It's in a country called Austria. It's a small country called Austria. Comparatively small. Okay, Machu. ഞാൻ ഫുഡ് കഴിച്ചിട്ട് വരാം. Yo, appreciate you for checking out the stream game. Okay. It's getting a bit better, but now it's just filling in this shadow part that kind of makes my face into this dark pixels. I feel like the size of these dark pixels should be small and maybe lighten it up, because the absolute black on the face kinda just ruins it. Looks like Minecraft. How many years? 2 years. It's copied, okay. Paste. And start. Where's files? Finder. Copy. I'm gonna stop the whole thing with this one. Like, not the stream. I was doing something else in between. And I'll stop it with this try. This would be the last try for that. For that. I'm curious what the image is gonna be. Nope. Yo, what the fuck is this? But hey, it looks aesthetic. It looks aesthetic, right? Fuck. It looks kind of aesthetic, not gonna lie. But it's not as good as I want it to be. But hey, it worked. I'm gonna close the no, I can't close the program. Okay. Cancel. Important nuances. While anions are generally stronger, the source note 2 conditions where an anion might be poor nucleophile, steric hindrance. A very bulky anion, such as tertiary butoxide, is a very strong base but a poor nucleophile because it is too large to easily attack a nucleophilic carbon. Just bases. Some anionic species like NaH or NaHMDS are used exclusively as strong bases and do not act as nucleophiles. Bro, you're in Austria and the time right now is 5:30, so you should enjoy the view, bro. I appreciate that, bro. But hey, I can enjoy the view anytime, but I cannot pass the exam every time. There's a limit to how much times I can fail an exam. So yeah, you know what I'm saying? So can you just explain? Is this chai? No. It's a cheap coffee. It's a very cheap coffee. Laughing emoji, okay. I don't know what's the joke though. I don't think you need the chat for vertical stream, right? No. Bro, don't lie. Do you have a girlfriend? No, no, right now. Studies. What are the main things? What are the main things that are mentioned? I'm still. Please, I need answer. I told you, right? No. No, no, no. Girlfriend as in partner, right? Relationship partner? No. I'm not in a relationship right now. Oh. Hard versus soft reaction centers. Polarizability, tendency of a charge distribution to be distorted from its normal shape by external fields or charges. Yo, chill, okay, chill. Why? Yo, I mean, I don't have a job. I still haven't passed all the exams. So, yeah, I'm still figuring those out. And, yeah, on the, during, during my process of figuring those out, if I meet someone I wanna have, if I meet someone that I felt like I wanna have a relationship with, I will go for it. But not right now. Right now, I don't. But there's a good news. I'm gonna head to Czech Republic from September onwards. Yeah, that's gonna be cool. It's a new place. It's gonna make a difference. It's gonna make some differences. Maybe, maybe not. Comparison of nucleophile strength. As we discussed earlier, this page introduces basicity rules for comparing nucleophiles. The rule when comparing nucleophile that have same attacking atom, the stronger base is always the stronger nucleophile. Comparing the stronger attacking atom. Okay, trends in the periodic table likely. While specified slides aren't in the current snippet. What do you mean? It is there. Go up. Yo, whoa, whoa. That just fucking took the whole thing. What do you think of Austria? What is the best place there, like for tourists? I heard the Alps Mountains is nearby. Alps Mountain. That's a very beautiful place. But I don't want to say I'm busy, but I never got the time to check these out. Like Alps Mountains are like crazy. It's gonna make your eyes go like Himalayas and shit. Oh, you're in Kashmir. Oh, okay. You also have beautiful places. Like places similar to these, the high mountain. But yeah, Alps. I don't know too much, but I know Alps mountains are nearby. Much more better than this. I don't know. I don't travel too much. But yeah, that's the only one I know right now. Then there's a lot of cities for. Austria has some cities. You could visit the capital, I guess, which is you know, you could see more people. I'm not a very big person in visiting cities, but yeah, if you want, you could visit cities. Oh. What else? Ah, you could go for skiing. Ski. It's basically you just slide down an icy mountain, but that's only in the winter. Okay, why you streaming? Any reason behind that? I think I told you, or was it someone else? Basically, 1 year ago, I was failing exams left and right, and I was like, okay, I gotta make a difference. I gotta make a big difference, and I looked up the things that I should do, And it was like, okay, I have to study. No matter what, I gotta study. Why not stream what I study? Oh, 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 oh. There we go. 1 year later, we're still here. I think the main difference this streaming made me, or gave me, or the main change, how do I say it? The biggest difference I felt after streaming would be that I study every day. Maybe it's like very little, but I at least sit down and look something. I feel like that's a big difference because back in the day, I do not do that. I only study when it's like exam time. And I gotta say, during stream, I yap a lot. Like I talk too much, which I need to bring it down. Because sometimes I just keep on talking and just did not study. But like I said, at first I usually didn't study every day. But after streaming, the number of studying every day, or the chance of studying every day, is getting higher and higher. Which is good. Which for me, I feel like that's a good thing. You're comparing methoxide, which is a conjugate base, and methanol, which is a conjugate acid. Because methoxide is much stronger base. It is more reactive. The results show lower activation energy. The basicity rule. This page establishes when comparing two nucleophile approximate the size, the stronger base is the better nucleophile. Okay. I don't think I have to learn too much about that. Reaction speed. Consequently, the mechanistic application. Your notes explicitly says that SN2 reactions require these stronger charged nucleophiles to proceed efficiently. Okay. Okay. So hard, small valence shell come in, little bonding. Transition state has little bonding. Connection of HSAB theory, Pearson's concept. This section introduces a hard and soft acid basis concept to help predict reaction outcomes. Hard centers, characterized by small atomic radii, high electronegativity, and low polarizability. Examples of hard bases include hydroxide, alkoxides. Soft centers, characterized by large atomic radii and high polarizability. Okay. Okay, so I don't have to look into this too much because it's not talking too much. Hard centers characterized by small atomic radii, high electronegativity, and low polarizability. Examples of hard bases include hydroxide and alkoxides. Good fate? I mean, bro. Fate. I guess fate depends on how you. Yeah, I mean, Austria is a good place, but still, I don't think it's only about the place. It's also about how you think, right? Maybe I'm wrong. But yeah, I still have a lot to improve. I think everyone has a lot to improve. Characterized by small atomic radii, high electronegativity, and low polarizability. Examples of hard bases include hydroxide, alkoxides. Examples of soft bases include iodide, thiolates. This rule applies these concepts to ambident donors. It states that under SN1 conditions, the hard, more electronegative atoms reacts, whereas under SN2 conditions, the soft. So hard versus soft reaction. So, oh fuck. What type of nucleophile was it? I want to be like you, like your independence. Yo, I gotta say, after 12th, things would start to feel different. Like till 12th, you're in school under care of your parents. But after that, I mean, I still know I still have friends who still live with their parents, but I know those who don't. And like after 12th, you just start to feel like, okay, I can do whatever I want. I can do whatever I want. I can plan however I want. But it does have a learning curve. Like I'm still in that learning curve. I still need to learn how to plan. I still need to learn how to manage stuff accordingly. For example, exams coming up, prepare for the thesis, look for jobs. Look for jobs. What else? Look for jobs. Look for plan more on what type of research I want to go for, or plan more on where should I go next. So there is that. Oh, not right now. Can you show me your tablet? It's an iPad 9th generation. It's like an old tablet. Hi Anna. Yo RKV, how you? எப்படி இருக்கு? நீங்க எப்படி இருக்குன்னு? Yo. So what was I saying? Hard and soft acids and bases. Hasab. Nalle Rukun Anna. Basjid Majid. Can I speak in Hindi? Yes, I can speak a little bit Hindi. मुझको कुछ हिंदी पता है, लेकिन मेरा हिंदी बहुत अच्छा नहीं है. मुझको मुझको survive. Oh, what's the word for survive? Yeah, survive करने के लिए पता है. But yeah. What was it? Stronger basicity. X OH minus greater than what's the terminology though? अच्छा, अगर मुझे आपकी जुबान like your mother tongue में कहना हो, my name is Mohammed Basit, how can we say? Oh, in my mother tongue, it's gonna be എൻ്റെ പേര് മുഹമ്മദ് ബാസിത്. That's how it's gonna sound in my mother tongue, Malayalam. Nucleophilic. Oh, nucleophile, not nucleophilic, nucleophile. Do you know physics follow? Yeah, I heard of this name. Physics Pala. Yeah. Why can't I pinpoint what I'm thinking about? So it's nucleophile. Stronger base, better nucleophile. Bro, why are you studying every day? Yo, that's the goal. I need to increase my hours, gang. But hey, why are you studying every day? Oh, I need to pass a lot of exams. After that, I need to pass even future exams. After that, I need to I need to look into things that I just don't understand at all. Better nucleophile. Poorer nucleophile. SN2 requires stronger nucleophile than, okay. SN2 prefers stronger nucleophile compared to SN1. Oh wow. I hate that. I hate that. Ah. So, there's a new shortcut or something going on my laptop whenever I take the mouse pointer to the top corners of the screen, it just home screen. Bro, I have completed 13 hours, like non-stop studying for 13 hours. Respect, because I cannot do it. I tried, but I cannot keep on staying focused for 13 hours. I've seen some videos where people like 12 hours, 10 hours. I'm like, what? How do you sit there for 10 hours? Maybe the more you study, the better your attention span gets better. RKV asking which department? I'm guessing it's for Bajit. That behavior is caused by a feature called hot corners or an accidental trigger or taskbar. Open the setting desktop and dock hot corners. Okay, let me check that. Let me pull it up because this ain't it. Bro, unplug your laptop. From what I heard, from what I understand, you could just leave the laptop plugged in. It's not gonna use energy from its battery. It's gonna take straight from the power source. That's what I heard. So it's not a big deal if you don't close it. Hot corners. Corners shortcut. Oh, get the fuck out of here. Hot corners. No, none. Ugh. Oh, much better. Oh, much better. I was writing. Okay. SN1 prefers stronger nucleophile compared to SN2 prefers stronger nucleophile compared to SN2. Did I say wrong sentence 2 times? SN2 prefers stronger nucleophile compared to SN1. Bro, try to understand. You don't a MacBook, you have a simple Lenovo laptop. Lenovo's don't have that feature. I gotta search. Does Windows laptop where you can use it simply plugged in? Yeah, it doesn't matter if it's a Mac or Lenovo. Most of the laptops does have this feature where you can just keep it plugged. Bro, have you seen any Tamil movies? Yo, you kidding me? Ninga kalikuna. I've seen a lot of Tamil movies, at least back in the day. The first movie that comes to my mind, Shivaji. Oh, Shivaji, Endiran. The have I seen Onion? Yeah, Onion. Oh, Yeramaravu. Oh, Vijay Talapati. Yeah, I've also seen some Talapati movies. A lot of Talapati movies. Talapati movie. What's the first one that comes to my mind? I think Kuruvi is the first one that's coming to my mind. But there are good ones. What else? Yo, a lot of movies. Shivaji the Boss. Yo, I've seen the movie Shivaji like a lot of times. Motta Boss. Oh, that was crazy. Shivaji was crazy. What else? Endiran. I haven't seen Endiran 2, but Endiran 1 was good. At least the beats were good. What else? I recently remember a lot of Surya movies. Surya. The one where he was a lawyer based on caste system. You have watched each and every video. Oh shit. Vijay movies in Hindi. Let's go. What would be the recent movie about? It was related to Lokesh Kanagaraj. J Beam. Yeah. J Beam. J Beam. There's also another one based on the flight. Oh, I forgot the name. But that's also a really good movie. I forgot game. Flight. Surere Potru. Yes. Surere Potru. Good one. Yo, ATX Moon, what's up? Let's go. I showed up on the feeds. Let's go. Oh man, I feel like my attention span is almost there. It's almost reached its limits. I can't stay focused. Cooked. Yeah, it's cooked. Oh, so I was looking into nucleophile. ATX Moon. You're the one of the only people I'm sub to. You and other 3 people. Let's go. Let's go. But what was I thinking? Yeah, I heard Pal World is doing really good. Like I seen some videos where people play the game and they're like, yo, I cannot stop playing this game. That's cause you the goat. The goat. Meh. 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 400! 400! God damn. Yo, I never played a game past 100 hours. 400. I mean, maybe back in the day when I used to play Genshin, maybe it's past 100, but 400? It should be a good game. Should be a good game. Tomorrow or day after tomorrow, I'm gonna try running that game. If it works, oh, that's gonna be good. I could play this game for 30 minutes. So you can speedrun the game. Is it like Pokemon? Yeah, from the gameplay, it looks like Pokemon. It reminds me of Genshin. It does. Fortnite. It does remind me of Fortnite right now. Fortnite right now. Okay. Ah. Okay. Pokemon, Zelda. Well, you know what? I'm gonna try running this tomorrow or day after tomorrow. Oh, we got boss fights. Oh, that's good. Okay. I like that. So it has the exploration. I've been 3 of them. Oh, okay. I'm kind of into the exploration type of games. There's 2 Crackathon stream. Well, basically one stream is the vertical one. This one. The other one is the horizontal. You watch it like this. Why not? I've been 3 of them. Oh, you beat 3 bosses. Oh, okay. It told me to. It told you to beat the bosses? The game told you to beat the bosses? So I'm guessing there's a story. Yeah. Okay, there's a story. Well, I'll try playing it next time. I hope it works. I hope it's not gonna end up like Team Fortress. A lot of lore, okay. You know what they say. What they say. What? We do not care. Oh. Oh, okay. So you just playing it for the love of the game. Love of the game. Grind. I see. I'll see how it is. Grind, yo. And it's a multiplayer, okay. SN2 prefers stronger nuclear. I got a multiplayer world with one of my friends. Oh, okay. So, multiplayer. Is there like a common multiplayer space? 2 days of playing. Damn. That must be a hardcore 2 days. Low DG. Low DG. What is DG? One level takes about 20 to 30 pals caught. Pals, I'm guessing, is the Pokemon alternative. A low DG. Mentioned at the very bottom. No, look at some gameplay. Yeah, just a minute. Mentioned below. Below the intermediate. And let me know what that is. What should I search? Search Blitz Pal World. Blitz. Pal World. There we go. It's like a person who plays Pal World. I hope I don't get copyright striked. I hope me no get no copyright strike.
What are these adorable little creatures?
And why are they looking at us funny?
There's a little chicken and a sheepy boy, and then oh, it's like a cat. I love it. We're gonna be able to tame those.
Oh, okay. The game.
It's like it looks like a chicken, maybe.
A what?
A chicken.
Skip ahead to half.
Chicken.
Yeah.
Chicken.
It's gonna ruin
They
it.
got their little hammers.
4,000 hit points. Oh, there's a giant deer intern.
A giant deer.
I nicked the deer. I don't
So
know
you
how
can
to
just
make
kill
those
it?
words right in my mouth.
I'll be there as soon as I remember to grab more arrows.
And I found a penguin. Found penguins.
You're finding so many cool things.
Are you in hostile? Like, yeah, you could say it. It's like a dorm.
Fired boy. Okay.
It does not attack. It does not
Don't
hit you
attack
back.
me. Nope.
Yeah,
I
it
told
does.
you not
It
to
does.
attack me. Did you not listen at all?
Okay.
I'm frozen in an ice cube.
It does attack you.
Yeah.
Oh,
My
wow.
chicken must really be laying them over there.
Oh, wow. And the penguin went straight to work on this new
He's
pal
a good
bed.
boy. He's a really good boy.
He is.
Okay, if I'm gonna Spider-Man
can
my
just
way
climb,
into the
yeah.
house and take a nap.
Yeah, it seems like.
Knocked an egg out of that one.
Oh,
So-
yeah, look at that. He's helping the campfire.
Oh, that's adorable.
Ah, okay.
In the middle.
So you basically do one of his newer ones. So basically, you set up a base. Oh, it's like new.
So I've got these little
Oh.
orcs that I need to fire missiles.
That's not Pal World. Three weeks ago.
Oh man, it is time again for Pal World 1.0 is released. I heard a shiny over here.
Yeah, new
Hello?
update has
What are
been
you? It's a
out.
chicken? Is that what? That worked. We're gonna aim
Boss.
down below. Gosh! Okay, you're in trouble. Hit you with that. Come on, come on. I want another Frostallion Nox for my
Yo,
collection.
what is that?
Oh,
That's like the
it's
Pokemon
close.
Pokeball?
It's close. Yes, sir.
Okay.
Boss kill. Logging foreman, Lord of the Underworld, and Legend. All right, that's cool. What do I not need? What are high quality bait? Yeah, let's get rid of the precious pelts. I'm pretty much maxed on money if I remember right. Precious entrails. Ah, exactly what I needed. Oh, and all of my pals just
Mm-hmm. Oh, you can use them to travel. Good.
What are you? Whoa. Hello. Are those just Ferellises? I think they are. Hi. You just a regular Ferellis? Ferellis.
Next boss.
Yeah, you
Okay,
are. All right.
okay.
Okay, all right. Don't kill.
Another boss.
Great type.
Oh, you could go underwater.
You're not. Pal tamer, researcher, ancient.
You know what this game kind of reminds me of? Is Pal World. Simi. Yeah, it does. It does have Monster Hunter Wild. Or Monster Hunter. No. Okay. Okay, it's not. Because I felt like Monster Hunter also has this hunting monsters, but I don't think you could save the monsters in a ball, so. But hey, let's try it. If it works, good. I don't know if it's a highly demanding, computationally demanding game. Low. Okay, so to catch more monsters, you need, or pals, you need balls, and for the balls, you need to grind. Okay, okay. I'm starting to get the gist of the game. Bro, it's Pal World, not support my device. Guess what? China comes into play. There's a SynDP9 says hi. Hello. Yeah, there's an app called Game Hub, which lets you play Windows game on your Silicon Mac. And it does not work every time, but I got Dark Souls 3 working, and I'm gonna try Pal World, and later in the future I will try Nier Automata, which is most likely gonna work, and maybe Dark Souls. Yeah, Dark Souls 3, it worked. So I need to check if Pal World. Have you ever played GTA 5? I tried the game like back in the day, but no, I have not completed the game. I never completed any GTA games. Whoa. Yeah. Strong nucleophile. Definition of delta G in your notes is defined as a free energy between transition state and the reactants. It represents the energy barrier that molecules must overcome for a chemical reaction to take place. It's the Gibbs free energy, change in Gibbs free energy. Or it's the activation. Okay, okay. So strong nucleophile, low activation energy. Reaction proceeds faster. Yeah. Pal World, I'll try it out. If it works, I could play once a week. Bro, open your browser and type Death Note. I know Death Note. I haven't seen it. I know it's an anime. It's like a must-watch type of anime, but I haven't seen it. But I know it's good. I take a potato chip and I eat it. Well, I'ma go, yo. I'll try it out and let's see how it's gonna go. It's not anime. Respect. Respect. Oh. Respect. Death Note. Okay. I don't think that nothing else is gonna come up when I search Death Note. Yeah, bro, come on. That's the first thing, Death Note. And there's a movie too. What's the rating? Oh, 8.9. God, that's a good rating. But have you seen JoJo though? Whenever someone brings up anime, I just go, yo, have you seen JoJo? Oh, Death Note by Crazy Games. Okay. Hmm. It's a free game. What is this though? So we got, oh, it's like online games. Ah. Can I just type? Oh shit, okay, okay. Yo, this is crazy. Wait. I'm gonna name. Okay. Oh no. Oh no. Okay, if I press backspace, it's gonna. You can play lots of games there. Have you seen House of the Dragons? No, I haven't seen any of those. Oh. Wait. Or I don't know. People that are. Oh shit, nah. What if I keep on typing? Oh, next page. Okay, okay. Oh. Not gonna lie, that's a fun game. I like this. The audio is a bit loud, but that's pretty cool. It's pretty cool. I did not know. I mean, I haven't played too much. Maybe when I was a kid, I tried playing some browser type of games, but yeah, I should thank you though. Thank you for letting me know. I thought you were talking about anime. No, you're talking about Death Note. Whoa, fuck. Nucleophilic convert to SN1. Yo, my religion. Well, I don't go to churches anymore. I used to go to churches back in India. Church is the Father, the Son, and the Holy Spirit. Strong nucleophile results in lower activation energy. You're a Christian, yeah, on paper, yeah. But I don't go to churches now. Like it's been like I don't know, well, more than a year since I went to church. So, yeah. Strong nucleophile results in lower act. It means you're atheist. Oh, I don't know, man. I don't know. I mean, I'm not gonna go to churches anytime soon. Does that make me an atheist? I don't know. Results in lower activation energy. And weak nucleophile results in high activation energy. Have you heard about Dhruv Rati? Yeah, Dhruv. Yeah, I do know this guy. I watched some of his videos. This guy's like the Ajay. Oh, bro. Ajay दोस्तों समझ चाहिए. He speaks like a proper formal Hindi. Both are SN1, SN2. Comparing two nucleophiles of the same size. Oh, I should also write this reaction. That's what I was gonna write. CH3O minus stronger than CH3OH in terms of what is it? Nucleophilicity. For SN2. A dot? What is a dot? CH2CO. CH3O minus gives SN2 conditions. I don't have to write that. Gives CH2 OCH2 OCH3. My channel, please, bro. What is your channel? Is this the one you're chatting? Is that your channel? Because I don't see any specific videos on your channel. Pencil metal ether. But like I said, I don't see any content in your channel though. What are you posting in your channel? So if it's the other way, SN1, CH2, CO minus, CH3OH. Conscious. Oh, that's your channel. Okay. I could look it up. But I still don't know what do you mean by a shout out. Which one is you though? A lot of channels. What? Do you have your channel in this? I don't know. No. So this one? So first it forms five, slowly down, bro. Slowly. What? Go down slowly? This one? No, that's 4 years ago. Bro, solo versus squad. This one? That's PK Games. No, that's also not here. So you're telling me this one, PK Games, Gamers. What's stuck on what? Oh yo, what's up, gang? What's up? I'm trying to find the channel of fellow Basit Majid. So it forms this, then CH2 OCH3 plus H plus. Wait, now so you got 3 channels now? Well, so it's a Free Fire gameplay channel. Give you some questions, gang. I'm fucked up right now. I mean, do you know what type of nucleophile is? This is the easiest part of organic. Ah, man, I feel really stupid because I don't get a lot of parts. It takes me a little bit time to understand. Is my channel monetized? No, I don't think so. What is the doubt? Right now, I kinda got it cleared, I guess. So what was it? Yeah, I did not realize. I thought all nucleophiles are basically anions, but no. It could be a solvent. It could be a molecule. So I was confused on that part. What else? And for SN2 reaction, stronger nucleophile with high basicity is preferred. I got that. What are these? I don't know. Bro, please can you show us the outside view for 1 minute? I gotta change the whole camera setup now. This gotta go down, gotta go up. Besides, it's gonna be a bit late. 8:06. I feel like I should call. Or I should just put the stop and continue in like 1 hour. Yeah, 1 hour. But can I cook in 1 hour? I'm not sure. I'm not sure if I can cook in 1 hour. And 2 hours. If it's past. Bro, we won't go there. Dreams, please show us. What? Like I said, bro, I'm pretty tired. What was I thinking? 2 hours, 2 hours. I think in 2 hours I could cook. Nucleophile basically means cation loving, so since oxygen has a lone pair of electrons, it donates it to the cation, resulting in bond formation. Since it is a weak nucleophile, it cannot hold the plus sign. You're talking about oxygen, or you're talking about water? Because OH minus has more basicity compared to H2O. Even H2O also has basicity, which part of the lone pair from oxygen, but OH minus has even more electrons in them, which gives them this negative charge. Yeah, I'm kinda my what's it called? What's that term? My attention span is kinda messed up right now. Well, I'ma end the stream. I'ma end the stream with the window, the curtain. Let me see how it's gonna look. What? If H plus reacts with alcohol, the oxygen gains a positive charge over it. I'm talking about OH group, resulting in OH twice, or OH2 with a plus on the oxygen. As a result, it detaches itself from the compound, leaving post-it. Okay. Yeah, that kind of makes sense, not gonna lie. Leaving a positive charge on the adjacent carbon. Yeah. So, yeah, it kind of makes sense now. Why why stronger nucleophile promotes SN2 reaction. Come on, I need to get past this PDFs really fast, but hey, I'm gonna end the stream with the outside view. Let's go. If it's visible or not. I learned this topic while gooning, man. Come on, it can't be that hard. Yo, shut the up. Oh. Is it visible? No. It is kind of visible, right? No, it's not that visible. But hey, peace out, YouTube. I gotta eat something. And we'll be back. I wanna be back. Somebody wrote something in the chat. Wait. Next live stream when? Within 2 hours. But hey, it's already really late. But I should be back in like 2 hours. Or 3 hours. But there should be one more. Peace. Make it 1. Yo, I gotta cook. Make it in 1 hour. I gotta cook. If I could cook pretty fast, then maybe yeah. Peace.